Okay, so compact section, flexure pa rin. Sample problem tayo dito. So let me just read this one first. No? A simply supported beam has a length of 9 meters. So drawing lang natin to give you an idea, kahit dito na lang. Ayan. So may beam tayo, simply supported. Okay, alam na natin yan. Sabi nga, dapat alam nyo na yan. Okay, alam na natin to, no? Okay, so yan yung beam. Okay, ang beam is a W shape na 16 by 31 A36 steel. Okay, so pag A36, alam na natin na F sub Y is 248 megapascal. Okay, tapos ang length niya is 9 meters. Okay, at meron din ito importante to, no? It supports a reinforced concrete slab that provides, so this is a key word, no? Keynote, dapat nyo alam. It provides a continuous lateral support. Pag ganyan nakita nyo continuous lateral support, wala tayong problema sa buckling. Okay? So, yung compression niya, off compression flange. So, ibig sabihin, wala kang problema sa buckling. So, automatic ka agad pag ganyan. M sub n, pag ganyan nakita nyo, automatic yan. The nominal moment is automatic M sub p, plastic moment. Which is equal to what? Yes, no? It's Fy times the plastic section modulus. Hindi na Sx, Zx na. Automatic yan basta pag nakita nyo ganyan, ha? Okay? Basta lateral support dun sa compression flange. Baka may magbigay ng trick question eh. Lateral support, continuous lateral support sa tension flange. Wala yun. Kasi nagbabackling lang ang column or ang beam, sorry, dun sa compression side. Okay? So, meron tayong service dead load, 6.6 kN. Okay? So, uniformly distributed na load na 6.6 kN. Okay, so W dead load service po yan, ha. It's 6.6 kilonewton per meter. Tapos meron pang sinasabi dito na live load. Lalagay ko na. It's 8 kilonewton per meter. W live load. Okay? So this load, isa pa to, this load is superimposed on the beam. Itong sinasabi niyan, this load na to, yung dead load. Okay? Ibig sabihin na superimpose, ito na rin, nakalagay na. It does not include the weight of the beam. So, yung 6.6, hindi pa kasama yung bigat ng beam, yung self-weight niya. Okay, so kailangan natin kunin yung sa code, or I mean sa handbook. Anyway, nandito na naman, kinuha ko na. And also, yung service live load nga given is 8 kN per meter. But the question is, does the beam have adequate moment strength? So, dadalawang checkin natin dyan, which yung LRFD tsaka yung ST. 6th edition kasi na tayo, no? So, sabi nga ng ibang estudyante ko, walang no choice. So, no choice. Anyway, balik tayo dito. So, solution. Okay. LRFD muna tayo. LRFD. Ganun din naman, parehas lang naman eh. So, unang-unang titignan natin, tingnan muna natin yung BF over 2TF. Given na naman eh. Ang BF over 2TF is given 6.28. Iko-compare natin saan? Naalala nyo ba? Iko-compare natin siya sa 0. Balikan nyo na lang lecture ko. 0.38 times the square root of E over Fy. Ano yung E? Well, 200,000 palagi, di ba, pag steel? 200,000 megapascal. Tapos yung Fy is 248. Isado nyo na rin, no? Buti naman. The answer is 10.79. 10.79. So, yun. Less than. So, okay. Yan yung o nga pala, yung BF over 2TF, ang tawag dyan is reactive element, no? So, yung isa pa, it's H over TW equal to 57.75. Session na kayo doon. 57.75. And i-compare natin siya saan? Tingnan nga natin dito. Dito. So, it's 3.76. No? So, i-compare mo sa 3.76 also, it's E over Fy. Ilan yan? So, kumpitin lang natin. I'll pause a little while. The answer is 106.78. So, therefore, the section is compact. And also, LB is less than LR nga ba yun o LP? Tignan natin ulit. Ito. LP pala. LP. And LP. Kasi dalawa rin yan. LP. Okay? Regardless na gano'n siya kahaba, pag sinabi, tandaan nyo ang keyword dito, kapag sinabi is continuous lateral support of the compression flange, hindi mo na kailangan computin yan. Alright, so LRFT tsaka AST, parehas lang yan, no? So, pwede ko pa rin alisin to, actually. For AST tsaka LRFT yan. So, next is the nominal moment. Nominal moment is Fy times Cx. Ang Fy is 248 megapascal. Ang Cx is already given sa handbook. Ayun, 885 times 10 raised to 3. So, 885 times 10 raised to 3. Ilan? Okay? Pwede rin ganito. Nasangkit lang. Okay? Pwede rin ganito. So, 8 or 248 times 885. Paano ba yung times 10 raised to 3 dito? Hindi ko alam. Bale, ito na. Diretsuhin na lang natin. 248 times 885 10 raised to 3. And the answer is 219.48. O bakit ganun? Hindi kasi gagawin ko na ng kilonewton meter. Okay? Kasi this will be Newton millimeter eh. So times 10 raised to 6 ang lalabas. Okay, so nandyan na tayo. What's next? So kapag LRFD na, yun na tayo. Pwede na dito sa LRFD. LRFD, ang maximum moment is equal to what? Okay? Kunin muna natin yung weight. Kasi maximum moment will be the weight, W, ano yan? W L squared over 8. Tama ba? Yes, that's correct, no? W L squared over 8. So, ano muna yung W? So, yung weight, in total weight, it's 1.2 W dead load plus 1.6 W live load. Okay? So, ano yung dead load? Naturo na sa concrete tong ano, no? So, pag 6 addition, 1.2, hindi 1.4 tsaka 1.7. So, yung dead load is given 6.6. Okay? Plus yung weight ng beam, 0.452. 0.452. So, 6.6 plus 0.452 equal to ilan? 7.05. Okay, ulitin ko ito yung weight ng dead load plus yung weight ng beam itself. Diniretso ko na. So, 1.6. Ang live load ay 8. Tama, 8 kilonewton per meter. So, ano yung total weight? Or lalagay ko W kasi ultimate na yan. No? or LRFD pala, sorry. Ultimate pagdating sa concrete. Anyway, the same concept. So, 1.2. So, ito yon. Pwede kong gawin ulit. Papakita ko lang sa inyo. How powerful is 1.2 times 7.05 plus 1.6 times 8. Tapos, equal to, ayan, 21.26. So, the answer is 21.26 kilonewton per meter. So, maximum moment, okay, is equal to 21.26 times L, 9 meters divided by 8. So, what is M max? Tingnan natin dito. So, pwede natin gamitin yan ulit. So, 21, bilisan lang natin, times 9 times 9 na lang, divided by 8, tapos equal 215. So, this is 215 point, ilan? 26 kilonewton meter. Ano yung M na nakuha natin? 219. So, pasok. Okay, since M max is less than the nominal moment, ito yung kaya niya eh. Kaya niya is 219.48. Then the section is adequate. Di ba? Well, kung ganyan. Pero hindi. Mali pa yan, di ba? Kasi, sorry I'm just kidding. Erase ko muna. Kasi ang equation is pwede kasi natin gawin tong, ito na yung mu. Ito na lang. M sub u is equal to 215.26. Iko-compare natin sa VMN. Ang VMN ngayon, that would be point, di ata pasado. 0.9. Mag-delay natin ito. Gamitin natin lang ito. 250 nominal moment times 0.9. 193 po. Mali ata. Bagsak, no? Well, ganun talaga eh. Bagsak. Sana dito lang, hindi sa grades nyo, no? So, 193.73 kilonewton meter. So, the section is not adequate due to flexure. Sad, no? Is not adequate for flexure. Okay? So, fail. How about sa ASD? Pasado kaya siya? So, tingnan natin. Ngayon, parehas lang naman siya, no? Ang magiging WA niya is W dead load lang plus W live load. Okay? Walang factor. Ang dead load natin, a total combination is 7.05. Again, yung 7.05, ano yan? Combination ng impulse tsaka yung weight ng beam plus 8. So, obviously, 15.05. Kailan pa ba natin i-calculator yan? Kasi 8 times 8, 16, no? So, tama na yan. Ngayon, ang M max or MA na lang, parang hindi na ako nalilito. It's W's L squared over 8, yung A. So, it's 15.05 times 9 squared divided by 8 pa rin. Okay? Sige, mamaya ako na-explain. 15.05 times 9 times 9 divided by 8 equal. Nakalimutan ko equal dito. So, 152.38 kilonewton meter. Okay, ano naman na i-compare mo yan? I-compare mo yan sa nominal moment divided by omega. So, ilan to? 1.67. So, 1, ano yung kanina? 219, no? 219.48. I-divide natin ng 1.67. Ito, hindi ko napakita na, no? 219.48 times 0.9 lang naman. Reduction factor yan pagdating sa flexure. So, this is equal to what? So, dito, 219.48 divided by 1.67 equal to 131.43. 131.43. Pasado ba? Bagsak din. No? Bagsak din. So, since MA is greater than this, then the section is also inadequate. Sayang, no? Malapit na pero hindi pa rin pumasa. Due to or inadequate to flexure. Okay? So, it's quite easy, no? Medyo mahaba. So, let me just recap everything. So, ang keyword, if continuously lateral support of the compression flange, okay? So, automatic yan. Ano na siya? Compact section. Pero, sinasabi kasi ng rule, kailangan mo din i-check or meaning wala na siyang torsional buckling or buckling effect. Pero, check mo pa yung ano niya, BF over 2TF if the section is compact. Now, for both flange and the, ano tawag dito? The web. Yung flange kasi ang tawag dyan is unstiff, yung web is stiff element. Okay? So, yun lang. Then, the section is compact. Automatic nominal moment is equal to MP, which gives you the yield stress times ZX. Discuss ko na yan previously in ZX, how to solve for ZX. If the section is built up shape, no? Then, check mo sa LRFD. Okay, nga pala, most common mistake for my 14 years in teaching. Yung WL squared over 8. Yung mga estudyante kasi parang hopefully, wala akong tinatapang estudyante rito. Pero may nangyayari. Ginagawa nila automatic WL squared over 8. Kailan mo ginagamit yung WL squared over 8? Well, if this is the case, no? If the beam is simply supported and has a uniform load. Okay? Yun lang. Other than that, hindi na pwede. Kung hindi na uniform load, triangular load, hindi na pwede. May concentrated load, hindi na pwede. Okay? Hindi ko na kailangan bigyan ng matinding load kasi ito pag ginagawa, ano yung pa yung load. Okay? So, nagpo-focus tayo sa theory of structures. I'm focusing on the steel side. Okay? So, that's why ginagamit yung WL squared over 8. Maraming way to solve for the moment. Correct? Di ba? Sa structural theory. Anyway, yun. So, compare mo lang yung ultimate moment sa nominal moment times reduction factor if LRFD. Yung moment, yung unservice load, compare mo dun sa nominal moment, divide mo ng safety factor or ang tawag dito, omega. So, yun. I hope may natutunan kayo. Thank you so much for listening.